Hey everyone, this is Derek, and in this video we're looking at compound inequalities. And there's going to be two versions. One version involves something called a union, and the other version is going to involve something called an intersection. And what we'll see with a union is, a union's kind of like getting married, actually, is where we take everything from one set, everything from the other, and throw that all together. Intersection is going to be more like what you would think of it as two roads. So it's not everything from each of the sets. It's only going to be the place where the roads would cross, that intersection. That solution set's going to be our answer. That will make more sense when I draw a graph of it, but those are basically the two ideas we're thinking about in this section. And we have a couple of ways we can express these. So this is our first notation, and then we'll see one more notation for the intersection here coming up. But let me start with what this little bit of inequality is. So this down here, let me write it a little larger in case people are having a hard time seeing it. This is saying x, well, -5 is less than x, and then x is less than or equal to 3. So another way of thinking about that is that the x has to be between -5 and +3. It can't equal to 5, could equal to 3. So when we see the x kind of sandwiched in between two inequalities like this, the graph is going to just be sandwiched in between those two values. So here we got our -5, and then 3 is a solid dot because of the equal sign. And then this is saying it's going to be everything in between there. So that's what that notation means. And then you'll see in a couple, well, one more example after this, there's another way to state that that's going to use this and here in just a second. Number 2, I wrote this a little bit larger. Looking at this, people kind of get, I don't know, weirded out by the fact that this has kind of 3 separate chunks to it. They're not sure what to do. I would recommend sort of ignoring one of the chunks and then asking yourself what you would do. And then the answer to that is totally right. So if we're looking at just this, we would want to get the x by itself, right? So the first thing we would do is we would add this 3. So not a big deal. The only difference now is that we're adding the 3 in 3 places instead of 2 places. That's it. So solving the continued inequality is the exact same thing as this. It's just that we have to do it one extra time. So here we would get -4, and that's going to be less than or equal to 2x, and then less than or equal to 10. And then if we're just looking at this, right, we would just go divide by 2, divide by 2. So we go divide by 2. And I'll slip this over this way. So this would be -2 is less than or equal to x is less than 5. So our x has to stay between -2 and +5. So back here, this would be our solid, and then 5, that would be open. And that would be that. Oh, and then for our interval notation, I don't think I did that on the last example. I should go back and do that. We would have -2 up to 5. And then this one back here, I just realized I forgot. So this would be from parenthesis -5 and then up to and including the 3. So actually, since I have this here, so and means intersection, the intersection of 2 sets A, intersection B. So that little symbol means intersection is the set of the elements contained in both A and B. So the important thing, it has to be present in both sets, and then that's what makes it a solution. So here, our solution set is going to be a graph like this. But I'm going to do 2 colors here just to kind of show, there's another one, what it is that we're thinking of, but the stuff I'm about to do in color is not the answer. I'll do the answer in a second here in black. So let's do x is less than 5. So we'll just graph that unto itself. And that would be that right there. And then x is greater than 1. That would be right here. And greater than 1, that would be going that way, right? And so then what this and means, or it could be shown as an upside down U, but that's our intersection. So that is saying, where do these two sets overlap? Where is the purple and the red overlapping? So for that, you would say right in there, right? So our solution set would be, I'll redraw this, from 1 to 5, open, open, and then the line would be in there. So when you're doing this on the homework, you wouldn't want to graph all this stuff that I just graphed. This is what you're thinking is the part in color, and then this is what you're taking away from it, because that's the point where both answers overlap. And then to say that in interval notation would just be from 1 to 5. This one, so it's another and, so it's another one where we're looking for where they're going to overlap like this. And we'll see in the next ones where they're ors, and that's where we're looking for anything to be a solution. But this is basically, we just solve each of these by themselves. So for this, we have 5x plus 4 less than or equal to 19. So I would subtract the 4 from both sides, and that will get us 5x is less than or equal to 15, and then divide over that 5. And x is less than or equal to 3. And here, this one, we have 2x plus 5, or minus 5 is greater than negative 3. So I'm going to add the 5. So that will be 2x. 5's are gone. Negative 3 plus 5 would make it a 2 right there. And then if I divide over my 2, x is greater than 1. So this is saying x is greater than 1, so that would be an open dot on that one, and this would be going like that way, is greater than 1. And this side is saying x is less than or equal to 3. So that would be a solid dot on this side, and then this one would be going that way. So if we think about where they'll overlap, it's just going to be right in between those 2 points. So that would be our solution set, and then for our interval notation, from 1 and then up to 3, and that's inclusive on the 3. Okay, so then number 5, so notice these ones are switching over to being ors. And so for an or, that was our union, and that's going to be any place there's graph is answer. So whatever we get, that's the solution. We just throw it all together. So here, x is less than or equal to 3. So we do that. Or x is greater than or equal to 7, so that's going that way. So that's our graph. And then to write our interval notation would be from negative infinity up to the 3. And then there's this gap here. And when we have a gap, the way that we paste these two solution sets together is with an or that union symbol back on the last page. And that was a U. So this means negative infinity to 3 or, and then 7 to infinity. And when you're typing that in the computer, you just type a capital U for that, and that will work. This is the same thing, but now we have to do a little bit of solving to get there. So let me write this bigger. So here, let's subtract 5 on both sides. And that's going to get us to 2x is less than negative 2. Divide over that negative or positive 2, and x is less than negative 1. So there's our first half. And we'll do the second part here. Subtract over the 4. And I get negative 2x is less than negative 2. And now this time, notice I'm dividing by a negative 2. So that means I got to reverse that inequality. So x is greater than 1. So our solution set's going to be less than negative 1 and greater than positive 1. And then interval notation on that, I'll go right above here. So it's going from negative infinity to negative 1. And then union for that gap, 1 on out to infinity. Okay, so for this last one, there's a couple of ways I could approach this. So this is 2x plus 2 less or equal to 0. I could distribute the 3. Something else I can do, if it's convenient, If this was a 7, I would not do this because then I'd have a fraction and that would make that difficult. But since there's just a 0 over there, easy enough to just divide out the 3 and I'm working, it just kind of saves me a distribute. So then bring our 2 over and that's going to be a negative 2 over here. Divide that out and x is less than or equal to negative 1. And let me rewrite this one. And so here I'll do the same thing where I divide the 3. I could get 12 and 9, but then I just, in this especially is a little better example, I'd just be working with a little bit larger numbers. Here you can see if I just divide that out, now I got 4x plus 3 greater than or equal to 15. And it feels a little bit easier than having 12x plus 9 greater than or equal to 45 because I'm working with smaller values. So then we'll kick our 3 over here. And divide out that 4, and x is greater than or equal to 3. So we are less than equal to negative 1 and then bigger than the 3. So this will be going that way. And again, this is an OR, so it's everything is our solution set that's colored in. So we're going to say negative infinity up to that negative 1, oops, bracket, I bad, union, and then bracket 3 to infinity.